Hi, I wanted to take a look at number 11 from page 130. And the idea of this video is going to be hopefully that you're mostly checking your work on it. So the first thing that it asks, it gave us this equation, and then it asked us to find g of 0. And so when you're asked to find g of 0, that means just like they put a 0 where the x was, you're going to put a 0 where the x was. Also, remember g of x or g of 0 equals blank. That gives you an ordered pair, 0, comma, blank. I just remember that these go in order. Okay, hopefully you can work ahead of me here. And hopefully you got -5 parentheses squared plus 2. By the way, always keep a parentheses around a negative number squared. That's going to equal 25 plus 2. And that means that my y value is going to equal 27. Okay, notice I just substituted a y for g of 0. You could keep writing g of 0 if you wanted. And so now I have an ordered pair 0, 27 that I'm going to be able to graph. The next thing they wanted us to find was g of 5. So again, I'm going to use this same idea. I'm going to substitute. See how it says g parentheses 5? They put the 5 in place of the x. So I'm going to do the same thing. By the way, that's going to make an ordered pair 5, comma something. Okay, 5 minus 5 squared. That's 0 squared. Now, don't think you're all done because you still have this plus 2, right? So g of 5 equals 0 squared plus 2. That means that g of 5 just equals 2. Or if it makes you feel better, you could say y equals 2. So that means I have an ordered pair 5, comma 2. Hey, no surprise. Guess what? That's the vertex. Look, in vertex form, don't you have a vertex of 5, comma 2? Haha, we didn't even have to do all that work. Then the next thing they ask for is g of 0. But before we find g of 0, I'd like to find g of 16, because I think that one's a little easier. Or g of x equals 16, sorry. So here they say g of x equals 16. And notice x, comma 16, right? Because here's the x, here's the y. Here's the x, here's the y. So that means I don't know x, I do know y. And I just replace g of x with the number 16. Okay, so now I'm going to solve using my SADMAP, my reverse order of operations. So, oops. So subtract or add, got to get outside the parentheses. I have to move that 2. Now remember, in vertex form, we don't have to set the equation equal to 0. We just solve. So I handle adding and subtracting first, subtract 2 from both sides. Again, hopefully you're pausing and you're just using mine for reference. Then I get x minus 5 parentheses squared is now 14. I need to get rid of this squared, right? There's no division or multiplication here, but I do need to handle the exponent. So I'm going to square root both sides. 14 does not have a perfect square. By the way, notice I use a plus and minus on this side. Remember, we learned that when we square root something with a variable, the other side has to have a plus and minus. So now I eliminated by inverse operations the square root sign and the square. X minus 5 equals the positive or the negative square root of 14. Now I need to split into 2 problems. And I like to write the x minus 5 first. It just makes me more comfortable. X minus 5 equals positive root 14. X minus 5 equals negative root 14. A couple things to notice. This positive and negative, they stay outside the equal sign. X minus 5 stays x minus 5 the entire problem. In fact, usually right here, I check. X minus 5, minus 5, minus 5, x minus 5, x minus 5, x minus 5. Did I just keep it plain old 14, 14, 14, 14? Yes. So now I'm going to add 5 to both sides. And for this one, I get x equals 5 plus root 14. And over here, I get x equals 5 minus root 14. And I'm going to make an ordered pair out of this. Remember, they told us basically that the y value was 16, and I just found the two x values. And so here's my ordered pairs. That's certainly not going to help me when it comes time for graphing. So what we can do here is we can use our Desmos calculator. And I'm going to put in 5, and then I'm going to put plus root 14. But before I do, I usually think for a minute. Square root of 14. Well, square root of 16 is 4. 5 plus 4 would be 9. So if it was 5 plus root 16, I would get 9. But root 14 is going to be a little smaller. So I should get a number a little smaller than 9. So let's see how that goes. Your square root sign is down here, 14. And boom, Desmos gives me the answer, 8.74. Great. So I'm going to round that to the nearest tenth, 8.7, comma 16. And then 5 minus the square root of 14. Well, if I had 5 minus the square root of 16, it would be 1. The square root of 14 is smaller, so it's going to be bigger than 1. Maybe a little bit bigger than 1. Oops. What's that? Yeah, okay, 1.25, great. So I can round that to 1.3. And if you're ever in a situation where you're not told how to round, just round to the nearest tenth. That's usually the safest thing to do. Okay, so I put those two numbers on my paper now. And I'm ready to graph. And the way I'm going to graph this is I'm going to make sure that I have my vertex, which it's vertex form, so I can already see that the original equation was a vertex of 5, 2. That means my AOS is x equals 5. They actually helped us find our y-intercept. G of 0 gives us a y-intercept. So we have 0, 27. Whoa, that's going to be way up here. Oops, you can't see that. It's going to be way up there for 0, 27. X-intercepts, remember, that's g of x equals 0. And those were no real solutions, which actually we didn't do that yet. So let's take a look at that. Forgot we hadn't done that yet. So another thing they asked us to do was to find out what happens when g of x equals 0. So what happens when we do this is after we subtract 2 from both sides and we take the square root, we realize that we have a negative 2 under the radical. That means that there are no real solutions. Now, it is cool to go ahead and finish the problem, but these are imaginary numbers, which means we have no x-intercepts, and this graph will not cross or touch the x-axis. And that's okay. Like a parabola that looks like this never crosses the x-axis, and a parabola that looks like this never crosses the x-axis. And remember, we were looking for g of x equals 0. That's the same as y equals 0, and that never happens in our parabola. Okay, and again, the reason is we got a negative under the radical. If you get a negative integrand on a square root, then you have no real solutions, meaning there's no numbers on our graphs that can represent this. The rest of the parabola is fine. It just means we can't have a y value of 0. So back to our graph. We have, for x-intercepts, we have none. We did find, we found this y-intercept is 0, 27, so we should be able to create a reflected point. It's easier to do that once we have the graph. And the other point that we found was when they gave us the 16. And by the way, these 2 points should already be reflected, right? So we have approximately 8.7, comma 16 and 1.3, comma 16. So let's draw our axis of symmetry. our vertex at 5, 2. The y-intercept, remember, not drawn to scale. Let me zoom out a little bit. Let's do, I'll put this at, let's call this, yeah, sure, let's call this 16. Really not to scale. So 8, I have a 1.3 comma 16 and 8 comma 16. These should be equal distance. 8.7 comma 16, sorry. Right, 8.7 and 1.3, they are the same distance from 5. This is plus 3.7. This is minus 3.7. So it did actually work. And both of those line up with 16. Then 0, 27, there should be a reflected point that also has a y value of 27. And how do I find that? Well, this is 5 units that way from the axis of symmetry. So this must be 5 units this way. So it's going to be 10, 27. So now I have all my points. I'll draw my parabola best I can here. And there we have it. I'm going to miss there. And notice that it never crosses the axis here. Every point is reflected. And I have my vertex. That's it. Hope that was helpful. Oh goodness, class starts in a few minutes. See ya.